All right, guys, in this lesson, we're going to be looking at significance test for the differences of means. And so our objective here is just to perform a significance test to compare two means and then determine when it is appropriate to use a two-sample T procedure. So again, just like every other test that we've done so far, we have to complete the four-step process in order to do this. So I know that I need to identify the population or the parameter, basically, and this can be done in one sentence just to define what the parameter is. I also need to identify the null and alternate hypotheses, and the null is going to be that there is no difference in the parameters, whereas the alternate is that there's going to be some difference in the parameters. You also must define the populations as far as what is mean 1 or what is mean 2. So on and so forth. I'll kind of go over that whenever we look at the example. But that completes your state portion of our test here, our four-step process. The plan portion is to state the conditions and confirm that they are met. So we know that it has to be random, it has to be independent, so the 10% condition must be met, or it must be an experiment of some kind in order for it to be independent. And it must be normal, and again, there are three ways to confirm. A sampling distribution for means is normal, and that is if the population distribution is normal, or if they tell us in the problem that the population distribution is normal, then it's considered normal. If the sample size is larger than 30, if both sample sizes are larger than 30, then the central limit theorem will ensure the distribution is approximately normal. If both of those cannot be found, then we have to graph the data and show that it is approximately normal at that time. And one thing to note on the AP test is that if you do graph, you must show the graph on the AP exam. So just be prepared for that. From there, for our do portion, we would need to find the T statistic or the test statistic. You can do this lovely bit of math right here, or you can just wait and see how to do it through the calculator, and that's a whole lot easier than having to input all of this into your calculator. I'll tell you that. And then also you need to find the p-value as well for the do portion. And then from there, all we would need to do is conclude at that point. But let's go ahead and look at an example of how we might solve this problem. So, does increasing the amount of calcium in our diet reduce blood pressure? Examination of a large sample of people revealed a relationship between calcium intake and blood pressure. The relationship was strongest for black men. Such observational studies do not establish causation. Researchers therefore designed a randomized comparative experiment. The subjects were 21 healthy black men who volunteered to take part in the experiment. They were randomly assigned to two groups. 10 of the men received a calcium supplement for 12 weeks, while the control group of 11 men received a placebo pill that looked identical. The experiment was double-blind. The response variable is the decrease in systolic blood pressure for a subject after 12 weeks in millimeters of mercury. An increase appears as a negative number. And here's the data. So group 1 of our 10 men were given calcium, and group 2 of our 11 men were given the placebo that looked identical. And so our goal here is to enter in this data into StatEdit and figure out what we need to figure out, basically. And so all of this we can use to solve the problem. Again, once you've entered that data into StatEdit, just hit Stat again, arrow over to Tests, and scroll on down to 4, and that gives you your two-sample t-test in this case. And then let's go through the first couple steps of the problem before we really dive into how to solve all this or how to state it. So again, we need to perform the state portion of this. So the parameter in this case is the mean difference in blood pressures and blood pressure drop between the calcium and placebo group for the black men who volunteered for the experiment. Our null hypothesis would be that there is no difference between the calcium group and the placebo group, and the alternate hypothesis would be that there is a negative difference between the calcium group and the placebo group. And so this is where you actually have to state what these means actually represent. So where our mean of C is the group assigned to the calcium, and our mean of P is the group taking the placebo in this case. So you do want to state what each one of these actually are. Okay, from there, we need to perform our plan portion of this, and so we are told that the subjects were randomly assigned to each group. So even though the sample or the subjects volunteered for the experiment, they were still randomly assigned to their appropriate groups, so that's still considered to be random. Since this is a controlled experiment, the 10% condition does not apply, so since it's an experiment, don't need to worry about whether or not those 21 men are less than 10% of the population. And since the samples are small, so since we only have 10 in one group and 11 in another, we can't meet the central limit theorem, and they don't tell us that the distribution is normal, so we must graph the data to see whether or not it is normal. And when we do put that into StatEdit and we actually graph that, we'll notice that the probability plots are fairly linear and the box and whisker plots are fairly symmetric. So because of that, we can assume that this distribution is approximately normal. Okay. From there, we need to perform the do portion of this, and so we would run a 2-sample t-test, which I just showed you how to do in the last example. And so once we've done that, you want to select data. You want to make sure that L1 is in there for list 1, L2 is in there for list 2. Make sure that you are checking to see whether or not the first mean is greater than the second mean, because that's only going to give you that negative value that we're looking for as far as the alternate hypothesis goes. And what happens is if we enter that in, they give us our t-statistic of 1.61 with a p-statistic or a p-value at 0.064. And so all we would need to do is basically state it like this, okay, for that do portion once we've entered that into the calculator. But you do want to make sure that you list that you ran a 2-sample t-test from the calculator for that. Okay, then if we were going to interpret p, so if we were going to interpret p, this is how we would do it right here. If the true difference between the calcium and placebo group is 0, so if whatever we stated was the null hypothesis is true, then there is only a p-values, only a 6.4% chance that we would get a sample difference of 5.27, and so again, that represents our sample difference. If the mean of C is 5, and then the mean of the placebo is negative 0.27, if we took 5 minus negative 0.27, that's going to give us a mean difference of 5.27. So that's essentially what we're checking for. Is that we would have a 6.4% chance that we would get a sample difference of 5.27 or greater in another sample of the same size. So you want to make sure that if you are asked to interpret P, that you use this to help you out. You would just have to change up the context or what you're talking about as far as the problem goes. But that's essentially how you would do that. And then finally, we would need to conclude down here. And so since our p-value is greater than our significance level, we would fail to reject the null hypothesis, and there is not enough convincing evidence that the calcium will reduce blood pressure in black men in this case. And that's essentially all we need to know as far as solving that problem goes. One important note before we end is that this is an experiment, and so it is about what does happen and not what did happen in the experiment. So you want to make sure that you are speaking in the present tense and not in the past tense. And this is where this lovely AP test starts to hit you. And so if your conclusion said those who took the calcium in the past tense or those that did take, the context would be considered wrong, and you would lose points for your conclusion portion of that. So you do want to make sure tense does matter in this case, and because this is an experiment, you're trying to project what will happen or what is happening in the present and not what has happened in the past, essentially. And so that's kind of the gist as far as stating in context goes. So you just want to make sure that you're careful when it comes to that.